In your free fall lab, uh, we are going to use 5 different masses. I label as ball 1, 2, 3, 4, and 5. And I'm going. This slide shows the very last table, calculation table on your lab report, and after this ball 4, you can go ahead and add another column because the fifth column for ball 5 is missing, so you can add a separate column to record the data. Right here you can add another column for ball 5. I'm going to show you how you fill this first uh, column and this data point and this data point in this your calculation. Let's consider the very first table, which has ball 1 for height 100 centimeters. So we know acceleration due to gravity, the book value is 9.8 meters per second square. So therefore it's better if you convert centimeters to meters before you start calculation for each uh, ball you choose. So let me delete this, and we know 100 centimeters is 1 meter, so I'm going to write 1 meter here. So T bar, this is average. T bar is average time. Average time. So for example, T bar is equal to, for ball 1 for 100 centimeter height, in your first table, in the first column, you have data points like 0.44. You can add 0.41 plus 0.43 plus 0.44 plus 0.41, and the last point is 0.41. That's the last data point. And if you take the average, you add these 5 numbers and divide by 5, you get 0.426. This is your average time. So you can record that number here, 0.426, and let me make it a little smaller, 0.426, and here you have to take the square of the average. So square of the average is, you can take the square of 0.426, which is equal to 0.185. Similarly, you can complete the average time for height 2, height 3, height 4, height 5 for ball 1, and then take the square. And same thing, height time average for ball 2, for height 1, height 2, height 3, height 4, height 5, and then square of this value and record in this column. And for ball 3, you can take the average for height 1, height 2, height 3, height 4, height 5, and then take the square of this number and record in this column. And if you take the ball 4, you have to do the same thing. Calculate the average time for height 1 and also height 2, height 3, height 4, height 5 from table 4, and the final table is table 5 for ball 5, and you can complete T bar and T bar square. And then once you have this table complete, you can plot height versus time, average time square, and then you can check the slope and answer to the questions, and from the slope you can calculate the acceleration due to gravity. I think that's also you can complete the rest.